Bismillahirrahmanirrahim. Uh, we start with chapter 5, first order logic. Okay, in first order logic, normally we see uh, a lot of predicate logic, quantificational logic, and also first order predicate calculus. It is a collection of formal system used in mathematics, philosophy, linguistics, and computer science. Okay, but normally when you talk normal logic, is symbolized reasoning in which each sentence or statement is broken down into a single subject, into a subject or a predicate. Okay. Basically, this one is symbolized. Okay, broken down into a subject and predicate. Okay, a formula in first order logic we have no free variable. Later I explain to you. Okay, for example, whether a formula such as field x is true must depend on what x represents. For example, okay, example, we have field x. Okay, is true depend what x represent. Okay, contents more on representation, syntax and semantic are basically for first order logic, using first order logic and knowledge engineering in first order logic. Okay. Okay, first order logic is also known as quantificational logic. First order logic predicate is a collection of formal systems that are being used in mathematics, philosophy, linguistics, and computer science, different as I have explained. And then first order logic uses quantified variable over non-logical object that allows the use of sentences that contain the variable. For example, we have a proposition such as Socrates is a man. One can have an expression in the form of there exists X such that X is Socrates and X is a man, whereby the there exists is a quantifier and while X is a variable. This one I have explained before. And then this distinguishes it from propositional logic, which does not use quantifier or relation. In this sense, propositional logic is a foundation of first order logic. Okay, please be remember first propositional logic is used to be a foundation of first order logic. Yeah, normally when you talk about the first order logic, together with a specified domain of discourse, over which quantified variable range, finitely many function from that domain to itself, finitely many predicates. We have many predicates defined on that domain. Uh, and then sometimes theory is understood in more formal sense, in which a set of sentences in first order logic. Okay. Okay, we have first order logic, aka also known as first order predicate logic, also known as first order predicate calculus. Okay, Okay, so far do you have any question? Ada soalan ke setakat ni? Okay. Okay, and then first order logic is standard for formalization mathematics into axiom. Okay, first order logic is standard for axiom. Okay, and then we have axiom that we subscribe, we describe two structure. Okay, and then much more powerful than proportional Boolean logic. It is a greater expressive power than proportional logic because we no longer need a separate rule for each square to say that which are the square are busy or pits. That another one is allows for facts, object, and relationships. In programming terms, that will allow classes, function, and variable to be defined. Okay, we have also advantage and disadvantages of proportional logic. Okay, first one, positive one is advantage. Okay, for the advantage, proportional logic is declarative, which means that it can contain a pieces of syntax that correspond to the facts. And then secondly, okay, this one is first, third, and fourth. Secondly, proportional logic that allows for partial, disjunctive, negated information, unlike most data structure and DB databases. And then proportional logic is compositional, which means that the meaning of B11 disjunctive by P12 is derived from the meaning of B11 and P12. And then number four is meaningful of proportional logic is content independent, unlike others natural language where the meaning depend on the context. And then also proportional logic is being used in artificial intelligence for planning, problem solving, intelligent control, and most importantly for decision making. Okay, normally this one is used in AI, artificial intelligence. Normally for planning, okay, we have problem solving, and most probably decision making. Okay, we have a weakness. Primary weakness of professional logic is lack of syntax. Lack of syntax, and then we have a very limited expressive power, unlike a natural language. For example, cannot say pigs because busy in adjacent square except by writing one sentence for each square. Okay, this one is the first one. Okay, secondly is lack of syntax. Lack of second. Lack of syntax for representing object in domain of interest. Okay, propositional logic only permits statement about the domain of interest. For example, it is not possible to have symbol for Socrates. Rather, it is possible only to make statement about the Socrates. Okay, we must have a complete syntax. And then the first order logic will assume that the word content object, relation, and functions. For example, for the object, people, houses, numbers, stories. Okay, for the relationships, we have red, round, prime, bogus, multi-story, brothers of bigger than, and so on. And then we have functions to describe of for describing logic. Okay, then logic in general, we have propositional logic, facts, ontological commitment. We have first order logic based on facts, object relation. We have temporal logic, probability theory, and fuzzy logic. Okay, and then for the epistemological commitment, we have true, false, unknown for propositional logic. For the first order logic, also same. Okay, same to temporal logic. Okay, what is ontological? Ontological is showing the relationship between the concept and category in subject area or domain. This one basically to show the relationship. Concept and category. Okay, and then for epistemological is relating the theory knowledge, especially with regard to its method, validity, and scope, and distinction between justified uh, concept and categories. This one is basically for knowledge, to represent the knowledge, and then and also for the reason. That's why we have output. Output either the output true, false, or unknown. And then we have degree of belief is member of 0 and 1, and then known for the interval values. Okay, so far okay ke? Ada soalan ke? Okay, this one is the syntax of first order logic. We have constant. Okay, we have predicates. Okay, we have functions. We have variable. We have connective. We have equality, and then we have quantifiers. Okay. The constant in first order logic, okay, denoted by the lowercase letter at the beginning, such as A, B, C, and D. And then the symbol may stand for Socrates. And then in arithmetic, it may stand for zero. Okay, in set theory, constant may stand for empty set. Okay, this one for constant. And then we have predicates. Okay, Predicate in first order logic modify or define the properties for the subject. For example, brothers, greater than, equal than, less than. Okay, basically predicate is define properties. Okay, when you define the property of the subject, you need define the relationship which bind two atom together. Okay, and then we have variable. Okay, and then we have connective. Okay, implication, double implication, and then we have equality. Okay, a component of first order logic, we have term here. We have atomic sentences. Okay, we have complex sentences. Okay, for the terms, constant, for example, rate, function of the constant, example, color, about one. This one function that describe the terms, describe and calling the terms in the domain of this course. And then for the atomic sentence, we have predicate relating the object with no variable. For example, John is the brother of Richard. Okay, and then married John mother, married John father. Okay, this one how you pronounce the atomic sentence. And then complex sentence when you combine the atomic sentences with the logical connective. Okay, uh, logical connective is the relationship between two atomic sentences. For example, here John is a brother of Richard. We have this junction, John brothers of the John father, and then we put the negation here. Okay, this one is complex sentences. We combine two atomic sentences and then logical connective. Okay, okay, then we have quantifiers. We have quantifiers that define the variable for the duration following expression and indicate the truth expression. You need to quantify for all, for some. Okay, and then sentences. This one is true in first order logic. Sentences are called true with respect to model and also for the interpretation. And then a model must contain at least one object, which means that it contains the domain element and the relationship among them. And then interpretation specify the reference for the constant symbol referring to object, predicate symbol associating with the relationship, and then functional symbol associating with the functional relationship. Okay, we have atomic sentence, predicate, term 1, term 2, term 3, until term n is true if and only if the object referred by term 1, term 2 are in the relation referred by the predicate. Okay, for example here, we have a person, this one person king, denoted by crown on head, is a brother. We have a, this one is, we call it as the uh, function symbol. Okay, and then we have a universal quantification. Okay, equivalent to a conjunction of instantiation because we're referring to object. P is true in a model if and only if P with the X, okay, okay, each possible object in the model. And then common mistake to avoid typically is the main connective with for all. Common mistake by using this junction, okay, as a main connective with for all. For example, here is a mistake because if you have for all, you cannot associate from one-to-one relationship. Okay, and then for the existential quantification, okay, equivalent to disjunction. For this one, you need to have the implication implies. Okay, existential quantification, you need to equivalent to disjunction. Disjunction. Okay, another common mistake to avoid is when you do the main connective with the for sum. Okay, you use the implication as the main connective with the for sum. Okay, this one is basically we use the disjunction. Okay, example, everyone likes McDonald's. Okay, we have for all x like McDonald's, and then someone likes McDonald's. Okay, we use the predicate. All children like McDonald. Okay, because for all you use the implication here. Okay, and then everyone like McDonald unless they are allergic to it. Okay, for this one you can use the disjunction or okay here or implication here. Okay, both are correct. Okay, for all x like McDonald or x allergic with McDonald, or you can say that X allergic with McDonald. Okay, for some, and it implies X like McDonald. Okay, properties of quantifiers for X is the same. Okay, this one is okay, it's same properties with the quantifier. Okay, and then we have a nested quantifier. We joining more than one quantifier. Okay, everyone likes some kind of food. You can combine for all y. For some x, food x is a food, and then y likes food. Okay, this one quantifier duality. Okay, not everyone likes McDonald. You put the negation. Okay, first one is also correct. Second one also correct. Okay. Okay, so far do you have any question? Kalau tak ada kita rehat sekejap boleh? Ke kamu dah ngantuk dah? Semua tak percaya je ni. Sekejap. Stop.